3. M prime of t equals negative 0.003 t squared plus 0.2. Did I manage to copy from the other one? Where m prime of t is the memory rate in words per minute. Words.
Did we already do that?
Not this one. How many words are memorized in the first 10 minutes? What am I asked to determine? The definite integral from exactly from m prime of t dt, indeed. So the integral from 0 to 10, negative 0.003 t squared plus 0.2 t dt. Exactly. Okay, what is the antiderivative of this? Negative 0.003. Yes, plus 0.2 t squared over 2. And this is from 0 to 10. Luckily, we don't have to plug in 0. I should write minus when I plug in 0, but you understand why I'm not. Because this is 0 and this is 0. So all I have to do is plug in 10. So then we have, and this is negative 0.001 times 10 cubed plus 0.1 times 10 squared. And this is 1,000, so this is negative 1, and this is 100, so this is 10. So the answer is 9 words. Okay, what about accumulated sales? Problem 64. Ready for 64? Okay. Melanie's Crafts estimated that its sales are growing continuously at a rate given by. Okay, that's their estimate. Good for them. So 64 on 402. So S prime of t is 20e to t times e to t. S prime of t is in dollars per day. On any day t, find the accumulated sales for the first 5 days. We have the function that is the rate of change, and we want to determine the accumulated sales. The integral from 0 to 5 from S prime of t dt, 0 to 5, 20 e to t dt. Remember, like with limits, like with derivatives, 20 is a constant. It should wait outside because it's a factor. So which function prime is e to t? E to t, 0 to 5. E to t is the only function that it's its own antiderivative and its own derivative. Right? I plug in 5. Leave the constant outside, don't bother with it. E to the 5th power minus e to 0. I plug in 5 and I subtract when I plug in 0. E to 5 is e to 5, but what is e to 0?
0.
Careful. 1. So this is 20 e to the 5th minus 1. And if you tell me you have in your pocket 20 times e to 5 power 5 minus 1, I'll say, huh? So I want 20, parentheses, e to the 5th, yes, minus 1. So 2,948.26. 2,948.26, and this is in dollars. The rate of change was in dollars per day, and this is accumulated in dollars for the first 5 days. Part B. Find the sales from the 2nd day through the 5th day. Find the sales from the 2nd day through the 5th day. And in parentheses, we have a hint. This is the integral. They should have said the definite integral, of course. The definite integral from 1 through 5. So now we want to determine the integral from 1 through 5.
That wouldn't it be 2 through 5?
It's because they want to include the entire day too.
Okay.
Yeah. So if you look at the hint, it says find the sales from the 2nd day through the 5th. This is the integral from 1 to 5. So the integral from, so that's part B, the integral from 1 to 5, from the same thing, right? So from 20e to t dt. I don't have to reinvent the wheel. It's the same thing. I get 20, and I get e to the 5th minus e to the 1st power. So I go back to my calculation, and I go to second and entry, and I'm going to change 1 into e. $2913.90. 2193.90. Okay, do we need more examples? Sorry.
219.
Do we need more word problems? I know I only have about 15 minutes left, less 12, 13. I'd like to explain this substitution rule. Ready?
Okay.
This is the last section. You don't have to do anything with the last section yet. I'll come back and do more problems and 4.4, which I skipped for a moment. But I just want to show you a few examples because Emily asked me today, how did they come up with this? How did they come up with that? So I just want to show you a few examples, and then I'll come back to 4.4 and then 4.5 again. So we are looking at 4.5, substitution rule. When and why would we ever substitute the variable for something else? Just to make it simpler.
Mm-hmm.
If the substitution makes it more difficult, then we don't need it. So a substitution is meant to be used when the integral is complicated, and using the substitution will change it into something simple, and you'll see how simple it is. Okay, so let's start with 46 on page 422. The integral from 1 to 2. Well, we have two different things. We have substitution rule for definite and for indefinite integrals. Okay, I picked a problem from the definite ones. So 46. The integral from 1 to 2 from x squared minus 1 to the 7th power dx. By the order of operations, we understand that if I want to expand this, I would have to raise this to the 7th power. You're going to find me here tomorrow morning still multiplying. We have a way of doing this, either combinatorics or Pascal's triangle. But if we don't know those, and we do it by brute force, it will take a long time. But that's not what I want to do. I don't want to raise it to the 7th power. I want to use a substitution that simplifies this function, right? Because when you take it to the 7th power, you will get 8 terms. And then you have to distribute by 8 terms, because if I have power 2, I get 3 terms. If I have power 3, I get 4 terms, one more than the power. So I have to find 8 terms and then distribute x and then find the antiderivative and then plug in 2 and subtract when I plug in 1. No. Which piece of this bothers you? Does x bother you, or does x squared minus 1? This is not a scientific way of thinking. X squared minus 1 bothers me. X is just a simple
x. But you have to distribute it.
Right, but after I get rid of this, after I change this into 8 terms, and I don't want to do that. So this is the piece that bothers me. So I'm going to say, let y be x squared minus 1. If that's the case, then eventually this piece will become what?
0.
Will become y to the 7th, correct? So if I denote x squared minus 1 by y, then this whole piece will be changed into y to the 7th power. Would you agree?
Yes.
Okay. So I cannot have x and y in the same integral. That's not possible, right? So now I have to determine dx. How do I determine dx? By simply differentiating, finding the differential of y. How do I find the differential of y? Can anyone remind us the formula? Of x times? Excellent. So dy will be, what is f prime of x? Excellent. Times dx. Would you agree? Let's see if this is in the problem somehow. It is. Here it is. X times dx. X times dx. I'm missing one piece, which is this little 2. That's not a problem. I can always multiply and divide by 2. That's never a problem, right? 1/2 times 2 is still 1. This piece would be replaced by y to the 7th. But what about 2x dx? What will I replace 2x dx by? Correct. So then the new integral becomes 1/2 the integral from, do not copy the limits of integration yet. Can anyone tell us what to write? I have to write y to the 7th multiplied by, what is this? What did we say was this?
dy.
Very good. Now let me ask you this. Would you prefer to determine this integral, or would you prefer to determine this integral? Would you prefer this one, y to the 7th, which is y to the 8 over 8? Or you would prefer this one that has the integral from 1 to 2 from x squared minus 1 to the 7th times dx? Which one will you prefer? This one. Perfect. Now, I cannot copy these limits of integration. These limits of integration, they are for x, not for y. So when x is 1, can you tell me how much is y?
0.
Perfect. So the lower limit, when I integrate with respect to y, is 0. Now plug in 2 and tell me what is the upper limit when I integrate with respect to y. Excellent. So then this is 1/2 y to the 8 over 8 from 0 to 3. Yes, I know it's not done. I'll have 1 over 16 and then I plug in 3 and I'm done. So we plug in 3. So this is 1 over 16, 3 to the 8th power, whatever that is. And what is it, by the way? 3 to the 8th, and I divide by 16. 410.06. 2, 5. This is how we use the substitution rule for definite integrals. Do we have time for one more? Any questions? So we use the substitution x squared minus 1 because it simplified the whole thing tremendously. But remember, if we use a substitution, dy has to be in the problem or easy to make. And when I change from x to y, there is no more x, and the limits of integration have to refer to y, because now the integral is with respect to y, not x. You cannot simply copy 1 to 2 here. That would be incorrect. Okay, please choose another. 58. Excellent. The integral from -1 to 0 from x cubed dx over 2 minus x to the 4th raised to the 7th power. Okay, what bothers you here?
2x, 2 minus x to the 4th.
Right, this is what bothers me, especially because it's at that power. So I'm going to say let y, you can use t, you can use z, you can use whatever. Let's use t this time, it doesn't matter. 2 minus x to the 4th. In all these situations, the function has to be continuous on this interval. If the function is not continuous on this interval, the function is not continuous when 2 minus x to the 4th is 0. Right? But that's a number that is greater than 0, so that's okay. It is continuous between -1 and 0. Good. So then I need dt, which is negative 4x to the 3rd dx. Can I make this in the problem? Yes. Here it is. I needed a -4, which I did not have. I needed an x cubed, which I do have, and I needed a dx, which I have. Multiplying the top by -4 and multiplying the bottom by -4 is multiplying by 1. But now I know that this is what, and this is what. And the bottom is to the perfect. But now I have to worry about the limits of integration. I cannot copy them. So when t is -1, -1 to the 4th is 1. 2 minus 1 is 1. Let's plug in 0.
2.
Excellent. So now this is -1/4, the integral from 1 to 2, from t to -7 dt. What function prime is t to -7? -1/4, t to -6 over -6 from 1 to 2. -7 plus 1 over -7 plus 1. So then I have 1 over 24, 1 over t to the 6th from 1 to 2. 1 over 24 stays outside. I plug in 2. 1 over 64 minus 1. When I plug in 2, 2 to the 6th is 64. When I plug in 1, I have to subtract when I plug in 1. So this is 1 over 24, and the top is -63 over 64. So -63. Oh, I can simplify. By 3, 21 and 8. So -21 over, correct me if I'm wrong, and I have to delete that. This was possible because we chose the correct substitution, and we made this integral from what it is into this, or this. What did I do here? Is it 51? Am I correct?
512.
512, yeah. Thank you. Any questions on, oops, sorry, it's already 6.